You might get the wolf reference. In that movie, there was a really big mess, and they had to call this gentleman, Winston Wolfe, to come in and tell them how to clean up the mess. And that's been primarily my main business focus for the last 20 years or so of consulting on SQL Server. Unlike him, I do actually get my hands dirty and do some real work. He was strictly suit and tie, hands-off kind of guy. Contact information, feel free to shoot me an email or tweet if you got any questions. I've done somewhere around 110 SQL Saturdays as a presenter. Once or twice a year I get dinged for being cocky, so I changed world class to better than average. And I get dinged even after they see that number. And they've done studies, if you do something for 10,000 hours, you're technically classified as an expert, so I should be pretty good at it. It's amazing how high it can scale, even without features like in-memory OLTP and column store indexing. It's pretty amazing. And I really enjoy making it go fast and scale up and out now. Like watching the light bulb turn on. That's why I've done so many presentations, do a lot of forum posts to help people out, and also help my clients get better at doing stuff with SQL Server. I'm not a BI person. I know some really good ones, so if you want an introduction, I can make that for you. And if you knew all the things that I've seen people do to and with SQL Server, it would just probably make you pass out. I mean, it's just amazing the things that you can do that you look at them and you just go, boy, that's just really kind of crazy or messed up. But the awesome thing is that SQL Server is so good, it will just keep on trying to give you the answer that you ask it or do the work you tell it to do until it just rolls over and dies if you have a terabyte on a 8 gigabyte VM or something. So, but you're going to learn today from a lot of the things that I see over and over at clients in my consulting business. And this is not even the tip of the iceberg. This is a snowflake on the tip of the iceberg of the things that can go sideways or be done suboptimally. So procedural and object-oriented stuff is not relational data processing. And when you try to squeeze that square peg into that round hole, it's not going to work out well for you. I'm actually doing a session later today, I think, on entity framework, ORM type badness, and we'll see some of the things that come from that. Stuff that other people developed, bad sources. 3 good things to think about whenever you read a blog post or some online resource. First off, who wrote it? Because there's some really dumb people writing stuff about SQL Server and about everything on the intertubes. When was it written? Because something that Paul Randall said was the best thing since sliced bread 15 years ago could be patently bad advice on modern hardware and modern editions of SQL Server. And the last one that most people miss, even if they get those two, is does this apply to my system? Because the SQL Cat team or the premier field engineers play with the top 1% of the top 1% of the biggest and baddest installations in the world. So when they say you should do something on your box because it made their stuff run really fast for their client, well, they might be playing on a box with 2 terabytes of RAM, 6 Fusion IO cards, and 128 physical cores. That's probably not your server, and if you do the same stuff, it may actually be worse than if you had not done it. So always think of those things. Team collaboration is really hard. Bad design, if you're stuck with bad design, sometimes you have no recourse but to just do greenfield development from the start. It's really, really sad when I go to clients and they're just chasing their tail trying to keep it going when it's just fundamental underpinnings of structures and schemas and code and things like that are just really poor. SharePoint would be one of those things that falls into that bag. We're stuck with 15 or 20 years of stuff from that design. I should actually line that out and put not testing, period. How many people in here actually have tests that they do in their code? Yeah. Write this down, tsqlt.org. You can now do repeatable regression testing inside SQL Server, and it's free and totally awesome. tsqlt.org. Some of the things I'm going to show you, there's no excuse for not doing right 100% of the time, even if you're up at 2:30 in the morning putting together a critical fix because something got really hosed up. So here we go. From here on out, it's just basically samples, demos. I'll put it up on I'll upload it sometime this weekend, I hope, and you'll be able to go to the SQL Saturday Prague main page, the schedule page, and look, and there'll be a download button there. So this one and my other session. By the way, you can open up the main SQL Saturday page and go to any SQL Saturday that's ever happened, and any session that you see of interest that has a download button. It's a great free resource. So all the demos are either self-contained, such as this one in TempDB, or they work off of a public-facing data set. So here we have a table of colors. And I'm going to go fairly quickly, but you'll be able to play with this at your leisure when you download it. So we have a products table that has color in it. And you could put 2 rows in there that have colors and do your testing. You could actually set up testing for this. And this query, which says, give me all the colors that are not associated with a product yet. And you can run this. And we put 2 in. We had 4. We get 2 out. That's what we expect. Those darn users will do anything that you allow them to do, even if you really don't want them to do it. And this is a case where we really didn't want them to do that, because now we get the worst possible thing that can happen in any data processing in any platform or system, and that is the wrong answer with no warning or error. So right there, we just gave someone too much medicine and we killed them. Or we bought too much stock and caused a flash crash, or broke the wings off the airplane because our analytics were flawed. Worst possible thing that can happen. Okay? So, point 1, design nulls out of your schema. Because if you allow them in, you're no longer in Boolean true or false. You also have to deal with this nebulous null thingy 100% of the time, or you get the wrong answer with no warning or error. Right? And if you do deal with it, then you probably got sprinkled throughout your code base, is null parentheses my field, comma, tick mark, parentheses, equal, not equal to tick mark, or 0, not equal to, all kinds of stuff. CPU burn, function around a column and a where clause, void the use of index seeks, bad estimates, bad plans, bad concurrency, 19 ways of bad. Okay? There's usually some default value that you can use that's meaningful to say, I don't know what it is, or I don't care what it is. Right? 0, minus 99, minus 1, 111753, empty string, something, and it gets rid of that trinary logic that you have to deal with if you have nulls in your system. Now, knowing that you do have nulls in your system, as in T-SQL, that's often the case, there's multiple ways that we can get the right answer if we know that we have to write our query to actually do this. We can say it not exist. We can actually specify is not null in the query. We can use except, and there's some other alternatives down here. Questions on that? Very important things there. Functions on index columns in the predicate. Table of customers. We'll create an index because we know we're going to be seeking on it, and it's very specific. We'll show our actual execution plan. This is a function built in this case, system function, around a column in a where clause. We get the right answer. That's always the most important thing. Any change you make or any code you write, you really should make sure that it gets the right answer. And here I am without zoom it up. Give me a moment. Now let's go. Anybody see the problem there? There's a bad 4-letter word on that screen. What is it? What's that? Scan. S-C-A-N. What do we want there when we have a non-clustered index in few rows? Let's seek. Run down the balanced binary tree, find the first row that matches, rip until you don't have one that matches, and exit. It can't possibly be faster than that. But scan says, touch every bit of every byte in my 700 million row table to get back a few rows. All off a disk, crushing the I/O system. They have to go into memory so they can be processed, forcing possibly all the stuff out of the hot buffer pool. So now your whole server tanked, and all the applications on it have to lift up the data that they need to process right now back again, send it to the CPU, burning that up to get a few rows out of a massive amount. By the way, note that I did not do this, which all of my clients do. What am I about to type here? So in not doing that, which you shouldn't, I took a shared lock on that 700 million row non-clustered index as I scanned it. So I tanked concurrency also. No insert, update, or deletes on that table. At least updates for any column that happened to be on that index. So what do we do about that? Well, we simply don't put functions around columns in a where clause, because we have to modify the data, and in doing so, by the way, we don't get good statistics out of this also. So now if we join it to other tables, we have bad estimates and bad plans, which could be scans and hashes, which also hits concurrency and performance. Always think logically, what does my where clause mean? What is my predicate? And then write something that just doesn't have a function, right? Can I do that?
Yeah.
How can I refactor that? Like and a percent.
Yeah, like.
So if you're not familiar with the semi-regular expressionist capabilities of like, go look it up. It's pretty awesome. Not full regex type stuff, but it's quite flexible and powerful. And the SQL Server engine, when it has a character-based column and it does statistics on it, it actually reads the characters and gives you statistical distributions that are valid for the characters in the field, which is very important for things like joins and plan shape and stuff like that. Right answer, always the first thing. Execution plan. Now I've got that good four-letter word that I wanted, which is a seek. Read down, find the first, run till it isn't, exit. Interesting side effect here. If you look down at the bottom, the optimizer rewrote my predicate. I didn't put that capital K row character in there, greater than equal. I said like L%. Key thing to note, the optimizer can do almost anything at once with your query as long as Boolean and algebraically it gives you the same output or effect. Okay. I note that may not be the effect you actually wanted, but that's a different discussion, right? So there we go. We just got a seek, we got good estimates. I mean, just orders of magnitude. Think about that. Scan a 700 million row index or seek maybe 50 pages of it. That's got to be an amazing performance benefit there. So now we'll build a sales table. It's kind of used for reporting, so we'll put our clustered index on the date. We'll put some rows in it. And now we'll have two functions around a column in a where clause. So again, logically, what does that mean? If you look at it, it's like all the stuff in 2009 and the month of January. Can I write a function that does that, or a where clause that does that without a function in there? I can. Note that is a table scan. All the datas, every bit of every byte. Last mod by, last mod who, varchar 5000 comment field, somebody put a MP3 on the table, all off a disk into memory through the CPU, blah, blah, blah. Bad stuff. So, new predicate. Greater than or equal to the very start of 1/1/2009 and less than the very start of 2/1/2009. Note, I cannot use a between here. If date time were involved, or time was involved in any manner, I can't write 235959 anything that's not going to possibly give me the wrong answer. And between is inclusive of both endpoints, so be careful with that one. And here, we get our seek. Navigate, run, exit. Questions? Magic bullet stuff here, seriously.
What if we use in like clause percent in the start?
Good question. What if we have like percent some stuff percent? You got to read every bit of every byte because it could be the last thing, it could be in the middle, it could be anywhere. So the engine now has to scan and not only scan, interrogate every character up to the length. I mean, there's some math it can do depending on how much you put in there and the length of the actual field values. So if I'm doing that and I'm searching for something that isn't like, you know, SZ or if I'm searching for words or whatnot, now I'm looking for some other alternative, which would be full text search, possibly. Lucene, do something outside the engine, find the things, the key values, and bring it back in. That's the fastest way to do that if we're looking for pattern matching words, things like that. So, good question. Shift F5, where are we at here? Incorrect subquery. I'll let you play around with this one at your leisure. I like to give more than I can cover so you get more bang for your time here. The big thing down at the bottom is always use aliases and put them in front of all the columns and all the tables. If you do that in this query, it will actually throw an error because the sale date in the correlated query in the bottom actually doesn't exist on the calendar table. It exists on the outer one, but it's still valid even though it gives you the wrong answer with no warning or error. It also helps when you have those really complicated 19 table joins with 73 fields. Where the heck does that guy belong, right? It helps you 6 months from now when you have to refactor it, or anybody else who comes and looks at it also. It doesn't take them 40 minutes to figure out what's going on with the query. Really helpful. Data type mismatch in predicate. So I've been consulting on SQL Server for 20 years now. Started my company in '99. A lot of performance focus. So in total, this is the single worst thing I see. So that should really make you sit up and pay attention, okay? Because I've seen some really awful stuff. So we have some onesies here. Just a few rows, that's all we need to demonstrate how bad it is. Now we're going to throw in 49,959 or 55 rows in a set-based manner here using a table of numbers. If you're not familiar with what you can do with that, go look it up. Oh, primary key. All right, let's cancel that guy again. So look it up on SQLServerCentral.com and you'll find all kinds of things that you can do about that. Let's see if that one works. There we go. So basically, table numbers goes from 1 to n, and that's all it does. But with that, you can do a lot of really nice things. One of the most useful one is to shred a delimited list into a table. Because that char index, comma loopy thing that you do in your function to make it, a table, horribly, horribly inefficient. Single set based operation to do this. So I would definitely look that up. Also, doing that kind of insert for that many rows is much better than scripting them out, where you get a log buffer flush for each one of these, unless you do some transactioning to make that go away. Again, we're going to seek on it, so we'll create an index. So I write an ad hoc query. I got one row with a non-clustered index, and it took 170 page reads. That can't possibly be the best plan. And in fact, it didn't even use the non-clustered index. Clustered index, it scanned all the table for one row. Now, why did it do that? So whenever you're tuning with graphical query plans, among whatever else you want to do, you will always compare two things. And whenever you have that much disparity between estimated and actual, in either direction, you lose. And lose to the order of 5 or 6 orders of magnitude of performance in some cases. Larger tables, it's that easy. You put the right data type in, and it's 5 orders of magnitude faster. Plus the concurrency benefits, not flushing everything out of RAM, CPU burn, all that other stuff. Either direction. And I will let you play around with where that 8333.3 number came from. There's some simple math in there you can do to say, hey, where did that come from? So why did that happen? Anybody note that? Let's take a look down at the bottom. We get a 4-letter T-SQL word called convert_implicit. Because there's a capital N in front of that ad hoc string that says this is a Unicode string. You can't compare Unicode and regular ASCII characters. Because if you did, if the engine did that for you, it could possibly give you the wrong answer. And Microsoft product team tries really hard to not give you the wrong answer where it's their fault. If you do it, well, there ain't much they can do about that. But not to give you the wrong answer, they have to convert the data to Unicode 2-byte to make sure they can do a proper comparison in the engine. And that, as you note, is now a function around a column in a where clause. And we get all the stuff that comes with that. So what do we do about that? Well, this is one of those where there is no excuse ever for not doing this. The right data type. Note there is no capital N right there. That's a sloppy developer or business analyst if they do that. For I/O, this is a 50,000 row table. Index seek, note the estimated and actual are identical. That doesn't guarantee that it's going to be fast because it could be blocked and sit there for 5 minutes. But it probably tells you that you've got the optimal plan, right? 50,000 row table, it's 42.5 times better on the reads and 28.5 on the cost. 4, 5, 6 orders of magnitude are just waiting for you to go back and fix these. Sadly, it's not only developers that do this because they simply don't go over to the object browser, drop down the thing, and look up the value of the, or the data type of the column. All right? Let's see here. I'm doing national ID. That's a nvarchar 15. To the best of your language's ability, you will make your data types or variables or parameters exactly the same as the schema, including the size. No excuses, no exceptions. Okay? But as I mentioned, it's not just developers that do this. It's also ADO.NET. If you default stuff and say, I read a blog post that said I should parameterize my queries, make that happen. You will get nvarchar parameters for all the SPXecute SQL stuff. And it will, you just can't buy big enough hardware to fix that. If you use Entity Framework or in Hibernate, guess what? They'll do that for you under the covers if you don't know what you're doing. And that's a really bad thing. So here we have a developer who didn't look it up. They put in varchar for a parameter, and I get my table scan. If I simply look it up and use exactly the same data type, concurrency, performance, everything is a win. Questions on that? You'd just be stunned at how much better your system will run if you have this in your system. Little story about a third-party ISV that I found this on, and it just was amazing. The company had spent an extraordinary amount of money building big hardware to run an medical records program on, and it turned out they actually didn't need it after the ISV simply fixed their parameterized ADO.NET code. They were not very happy about that. Predicate evaluation order. I'll let you play around with this one. The key thing here is Don't do multivariate fields like this, where some of it's maybe numbers and some of it's not, and you need to process the numbers, but not the character stuff, because it'll break really easily. The other is learn how to use the awesomeness that is case in my example here. Let me go show you that. You need to look up the case statement. Exceptionally powerful and flexible, including stuff like pivoting. You can do like a 12-month stuff in a single pass through the table. Very, very powerful. Outer joins, placement of predicates. Very, very common way to get bad data. So we have a customers table. Pay attention to Jeff Gordon and Julie Peters. They will be our problem customers today. So we place some orders in our orders table. And note, there's no 4. Julie Peters didn't buy anything. And Jeff Gordon didn't buy anything after 1/1/2009. And that's going to be our problem. So let's break down the query. Give me all my customers. Give me orders if you have them, based on some key join. If you don't, what do we get back? Does anybody know? Get a null value for any field that we reference, right? But that still means that we get all the customers. And then the order date has to be greater than 1/1/2009. And we do a group by and a sum, an aggregate. This is a report. And vice presidents' heads will literally explode if you show them a null on a report, so we have to coalesce it. Well, coalesce and is null, that's kind of a religious discussion, so we won't go there either. And let's see how it runs. Wrong answer, no warning or error. Because I said, with my logic, give me all the customers. And if they didn't have it, I should get some nulls back out, right? I lost 2 customers. Gave someone too much medicine, and I killed them. So why did this happen? Anybody know what the real bugaboo is there? That guy right there. Remember, nulls don't compare. I do get nulls back out of the orders table. But nulls don't compare to anything. They're whacked off, right? Just gone. And by saying the order date has to be greater than that, I filtered out Jeff Gordon as well, because he didn't have anything greater than that. Right? That kind of where, that's a thou must have this situation. And we can't for Julie Peters or Jeff Gordon. So a friend of mine a long time ago wrote the start of this deck, Playman Ratchev, and he goes through a nice progression you can go through, which shows all the ways to join this, starting with a cross join, which is A times B. And then you get to see what happens with the data as you change things around. Inner join, who did we lose out? Julie Peters, because she didn't have any. Left join, we pick them back up, and then put the predicate in, and we see that's where we lost it. So here's the rule. If you left join to something and you need to filter it, you put the filter, the predicate, in the join clause. Now, over there, where the orders table is and we're doing our grab, we also say filter it. If you got it and it matches the filter, send it back. If you don't have it, send it back a null. If you have it and it doesn't match the predicate, send it back a null. And now I'm going to get all my customers, hopefully. And I do. Picked up Jeff Gordon and Julie Peters. But you got to know that's the way to do it. So let's take it one level deeper. Classic order details scenario. Put some order details in there. So we'll break it down. Whoop. Control 1. Let's do it there. Give me all my customers. Give me orders if you got them. Give me the order details for the orders. And that guru guy said to put the filtering in the predicate, so I did that. And I'm even worse off. I went from 3 to 4 to 1. Why did that happen? Inner join says thou must have a match, or you get filtered out. So the rule is now, if you left join to anything, thou shalt also left join to it for the remainder of the query. Left join, left join. And now, 1, 2, 3, 4 customers. Questions? Really, really important and easy to mess up. Really, really easy to mess up. Subqueries return more than one value. Leave it to you. But if you have a select or subselect, if it returns more than one thingy, it throws an error. The good news is it throws an error. It doesn't give you the wrong answer with no warning error. Unfortunately, some random 2:23 in the afternoon on a Tuesday, your application starts breaking. Could be suboptimal, right? So play around with that. Select star. Don't do it. Any questions? Actually, it's pretty easy now with, you can drag a folder, the column folder over, and it actually script it all out. I mean, there's all kinds of code generators that build the columns. But far, far more important than scripting out all 63 columns on names on the table when you in your select is to ask yourself, do I need this column at all? Oh, if I had a nickel for every time a developer has pulled all the stuff back when they needed some smaller set of that, often 2 or 3 or 4 columns, I'd be living on an island right now, like Hawaii. Because you just don't bring the data back. If you do, you got to lift it off a disk, put it into memory through the CPUs, bundle it up in a TDS packet, send it over the network, rehydrate it on your web tier, middle tier, whatever, possibly blowing it up to get the few columns of data that you need out, right? So the fastest thing you can do in SQL Server is actually nothing. And if you take the columns out, it's an infinite performance improvement because it's some work divided by no work, right? It's kind of funny, but actually it adds up to being a pretty serious issue. Also think about the scenario where you really do only need 3 columns and you got an index that has those 3 columns on it. Ooh, don't have to touch the base table at all. No locks, no reads, no lacks, nothing. Concurrency's up, right? Covered index situation. Huge, huge, huge benefits come from not doing select star. This one's one of my favorites. I wrote a chapter for the SQL Server MVP Deep Dives 2 book entitled Death by UDF. It's the best chapter in the book, I promise, and very appropriately named as well. It's so bad, I'm going to demo it in Northwind, which you could run on your Apple Watch, probably a bunch of instances at the same time. So when they first came out, the developers were like, code encapsulation, code reuse, hooray, because that's their mantra, right? Write it once and use it 33 times. So I send it an order ID. Always use with schema binding on everything that you can possibly use it on. UDFs and views are the big ones there. There are some really significant reasons for wanting to do that. And I add up the total dollar amounts for the order details and I send it back out. And I have an appropriately named stored procedure where I use this in an aggregate and in a not very restrictive predicate. And I'm going to go clean this guy up. Control, Shift, Delete. Go up. All right. So run it. Wow, it's really fast. Well, it is Northwind, and it is a Core i7 with 8 gig of RAM and an SSD, so it should be fast. 823 rows out. But Profiler says I had 4,000 rows. So that's kind of funky. Here's a freebie. Run it again. Second execution. Look at the substantial difference in work done on the second execution. Why? Anyone who was not in my pre-con yesterday? Anybody know? Profiler is showing you what happens the first time you run a query. You have to have a map on how to actually do the query, right? You need directions, a query plan. And we see the cost of compilation in Profiler. So don't tune the first execution of something small, because the cost of compilation dramatically skews what you're looking at. Okay? So now let's go and do our tuning in here. I almost always have that on, and this guy on, actual execution plan, when I'm doing tuning. So now let's run it. Well, first thing off, down at the bottom here, somebody's lying. We'll get back to that. Because that's 27, and we saw Profiler was 3,300. Well, now it's even higher. Look at the CPU, duration, read difference. The CPU and duration are the biggies. Why did that happen? So anytime something is different, you go, what changed? So what changed between execution 2 and execution 3? I did two things. Set statistics I/O on. I told the engine, track the I/O that's done. That's non-zero work. Send it back to me. Also non-zero work. Way more importantly, I said, send me back that actual execution plan. And that is a big fat pile of ouch. Right? Doesn't look like much there, right? Although there's some really neat things in the query plan, but we won't go into those. But look at this. This is a simple Northwind query, and look at how fat it is. All that. So here's the situation. The Heisenberg uncertainty principle says if the act of observing something, in that case at the atomic scale, changes what you're observing. We actually see that here. Right? We said track this stuff and send it back. We observed it, and we affected the work that was done. So don't tune in both places. Now I'm going to turn that back off. And I'm going to turn that off. And now I'm going to do something that you should never ever do in production unless you want to crush your system. So there's my tuning template. Note that is exceptionally tight. I have run it to local disk on servers with thousands of things per second with very moderate, actually pretty small overhead. But what's not on there is something that's on the default tuning template for Profiler, if you happen to use that, which is statement completed. And I'm going to put the other one on. Now let's run our little guy. Really fast. And yet, over here, what's that? And that, 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 and that. Ad infinitum. That's the guts of the UDF. So scalar UDFs and multi-statement table valued functions get us row by agonizing row processing. Essentially a cursor under the covers, because they're not baked into the execution engine. And we know that cursors are inefficient, really inefficient in SQL Server. Every row in that set was sent through the UDF twice. Once for the projection, once for the predicate. Stunningly bad performance. I've shown clients millions of executions of a single UDF in a single select statement. You can't buy big enough hardware to fix that. So what do we do about it? Well, first thing we can try, or we may want to try, is an inline table valued function. Note, it is just a table, which means it is only a select statement. There's no variables, there's no ancillary data access, there's nothing but a select statement. And because of that, this, unlike the multi-statement and scalar UDFs, can actually have proper statistics evaluated, so we get good plans. It can be parallelized. You may not have known that those two things void the use of parallelism in the engine. So you got a nice, awesome enterprise data warehouse with a billion-row fact table and enterprise class hardware, and you have a UDF to do something, you get one thread to scan that table. And that's probably going to affect your performance. So these guys, though, can do all the good things that we need with set-based processing. And let me turn off this awful statement level profiling. Really, really, really don't do this in production if you have cursors, UDFs, ORMs. It's going to crush it. Okay, let's try again. 35. Let's set statistics.io on again. And we'll talk about that lie that I was telling you. So now, 11, 22, 33, 35. Exactly what Profiler said. Because remember, scalar and multi-statement table value functions are not executed or not integrated into the execution engine. So the engine doesn't really know what's going on, so it lies to Management Studio, which lies to you. So if you tune your UDFs in here, you're like, ooh, that's cool, I'm awesome. But it really isn't. But now we see reality. We also see that, well, the plan, you're usually going to get nested loop joins into that, but it's set-based, and it can go parallel. Note we have to use the cross-apply. Paul White has 2 really awesome blog posts on SQLblog.com about how to use cross and outer apply. You really want to put those in your bag of T-SQL tricks if you haven't used them before. Best way to do it is to just make it a set-based statement. Integrate the guts and logic of the UDF into whatever statement that it's affecting or used in. I'm joining the details, I'm doing my aggregate. It's a post-aggregate filter, so I make it a having clause. And $35, 63, oh, wait a minute. That guy said don't tune the first execution, and poof, it drops to 35. So UDFs can be really complicated. I've had scenarios where I've used 3 temporary tables. Note, I did not say table variables. We won't use those anymore, except in edge cases. To take the logic of a really complex UDF and make it an integrated set-based solution. And it was repeatedly 4 orders of magnitude more efficient with 3 temporary tables. That should make you sit up and pay attention, right? Questions on that? Anybody? If you got them in play, take 2 business cards. But you, seriously, they just got to go. They really do. Now, if we get the chance, I want to show you one of the slickest pieces of code that I've ever seen, which was a date formatter that a client wrote. And it was just devastatingly bad for their performance. Cursors, whiles, don't use them unless it's right. And if you're prior to 2012 and you're doing a running total, guess what? A cursor is almost always the most efficient solution, believe it or not, despite how bad they are in SQL Server. Now, if you're on 2012 or newer, awesome sauce in the windowing function enhancements that the product team baked into the engine. You can do single pass running totals on your data and a bunch of other types of analytics with lead and lag and stuff like that. Really incredibly powerful. If you are going to use cursors, they should be made fast forward, or as Hugo Cornelis showed, in some cases, local forward only, static read only can actually be a bit faster than the highly optimized fast forward. Okay. Triggers and multiple row. This one is also near and dear to my heart. I had a client that came to me, they had ported an application from Oracle, which actually has an option in their triggers that will cause it to iterate the triggers. And that didn't exist in SQL Server, so they simply removed that as they ported the app. They just did a file grep and stripped them all out. Well, triggers are often used for auditing, and that's what we're going to show here. So this client brought me in for a performance review because the application was horribly inefficient for a bunch of reasons. And at the top of the 17-page findings document that I gave them, it said on the front page in 72-point red capital letters with 3 exclamations at each end. Literally that. It said, you must change every trigger in your system or you will go out of business. So that's, to the Vice President of Development for a performance review. So we'll think about what happened on that. Create the trigger. So auditing, we can see the before copy and the after copy, if you will, logically anyway, of a modified row. And we can grab that information and put it into an audit table. And that's what we're doing here. So we have 3 rows in our table. And I know I got a problem because 1 is not equal to 2. One of those is the trigger and the other is the update. Well, let's see which is which. Hopefully my update with that simple where clause actually did affect 2 rows. And indeed it did. My audit table, however, has just 1 row. Where did the other one go? Poof. Off in the digital ether, never to be heard from again. Too much medicine, dead patient. Now it's auditing, so who cares? Well, in the US anyway, there's these things called HIPAA for healthcare stuff, and PCI, which you also have to deal with, for protecting, credit card information and stuff like that. If you do auditing wrong, in the HIPAA world, certain things that you do wrong in there carry a $250,000 US per occurrence penalty. The biggest companies in the world stand up and take notice when you throw around that kind of damage. So, did anybody note why that happened? How many things can we put in a variable? 1 max. One of those 2 rows went into the variables. And because triggers in SQL Server fire per batch, if it's 100 rows, 1 goes in, 99, doesn't matter. They don't iterate. So this company kept me on for a while to help them fix the plethora of things that were messed up. And I left. I stopped working for them at 8 months into it. They fortunately had paid all my invoices because I saw what was coming. Every time I was there, what are we doing with the triggers? We don't need to worry about that. 14 months after the review, they went out of business. And I told them it was going to happen. And they had a really awesome product too. It was really a shame. So the rule is you must have some way, and I don't care if it's a triple nested cursor, you got to have a way in your triggers to process every piece of data affected by the statement. Period, end of story. Okay? We prefer to make it a nice set-based way. It's really a frowny face. If we're doing data modifications, we should be doing some transactioning and some error handling, right? But we got to do some way to handle all the data. So now I'm going to update the second 2 rows after I hit F5 instead of F4. Right? And I didn't drop that other trigger, did I? That's why I got 1 and 1. Yep. Just a second here. Let me redo everything. Make sure my audit table. Okay. So now I'm going to do that second one. I had not dropped the trigger. I missed that one. Sorry. 2 rows and 2 rows. I updated the second 2. Now here's where some people get a little twitchy because they're out of order. And humans have this thing about order. Right? So Speaking of the fastest thing you can do is nothing in SQL Server. If you have an order by, it's a fat, huge, temporary table type object, right? It's TempDB hitting. Now it may stay in memory if you got enough of it, thankfully, but it might spool down to TempDB and crush your box. But developers, and I can see the reason for this, sometimes if you put the data in order, you can very easily see that you didn't miss something, there's nothing out of sequence or anything funky like that. All the stuff is there. But if the business requirement doesn't say that the user has to see ordered data, take the order by out, because it's an infinite performance improvement. Better yet, if it's a small set of data, don't even do it in SQL Server. Do it in the middle tier, which might be 3 boxes. You might have 1,000 web servers, little Linux pizza boxes. Do it on their phone, their web browser. Use their power and cooling and CPU and all that stuff to sort a small data set or format a date or a money or something like that, right? Always look for things to take out of SQL Server so that it can focus on the things that only it can do. Therein lies great performance and great scalability. Questions here? Big deal. So we got 7 minutes left, I think. Excellent. So I'm going to skip the is no or. Might get to that one too, but I'm going to show this one. Remember I said we're not going to use table variables anymore? Well, first I'm going to try to get onto a data set that I can use here. I forgot I have my travel laptop, so it doesn't have the old AdventureWorks on it. Let's see what we got. Okay, so that has 8. Yep, okay, so this will work. So product ID and count star, we're basically doing a distribution analysis of the values of product ID in the transaction history table in AdventureWorks. Freely available from codeplex.com. So there's very few with certain products, and relatively a lot, 3.5 orders of magnitude more for others. That's known as data value skew. Now, whenever you have data value skew, which most people do, in some tables, if not most of them, you have to do things differently, or you can't buy big enough hardware. Also, if you have widely varying input parameters, you have to do things differently. The thing often there, believe it or not, is option recompile. Sadly, we don't have enough time today to dig into that, but I'm going to show you an example here where a 1-row, 1-column table variable gets you a bad plan some of the time, and a temporary table gets you the right plan all of the time. What's the devastating flaw with table variables that make that happen? They are lacking one very important thing that temporary tables can have, and that is statistics on the value or values in a column. And without that, all is lost. Because it can't know the value I'm putting in there, is it really few rows or is it a lot of rows? And without that knowledge, it has to guess. And I don't want my optimizer guessing on the statistical distribution of the rows coming out of any operation that it's doing. If it does, some of the time, I'm getting a bad plan. So here I'm going to put 3 rows in. You can do this with 1. Okay, and let's show the execution plan. Okay, I get the 3 that we saw. Estimated number of rows. If you have table variables, you'll see that number a lot, because that's the guess. 2014, with a service pack and a trace flag, I think. Is that right, Uwe? Did it take a trace flag? No trace flag. Okay, so they said, well, this number just is messed up a lot of people, so we'll pick another guess. And it's now 100 rows. Still a fabrication. Has no basis in reality for this thing right now on your system. Okay? So fortunately, it actually was very few rows. Excuse me for bouncing around here. And I got the good nested loop plan that I want and expect for small numbers of rows. But what if I put the big one in there? And actually, in this case, you can see it's just one row. The bad one. Let's see here. Down here, I got 4187 rows. Right answer. Woo! And now, I come out of there with an estimate of 1. The problem is, it doesn't know when I get down here that I've got a lot more for that value than the other value. But the engine doesn't know anything, the optimizer doesn't know anything about the value because it can't create statistics. If you set up Profiler with a certain thing, you can capture the creation of statistics. And you can see this happen. I encourage you to do that. Capture the Profiler event for creating a statistic. You will see the engine create the statistic on the temporary table. And because of that, as we'll see in a moment, oh, by the way, it says here 30,000 page reads. If you loop a lot, I've seen logical IOs in the trillions for queries like this. You can't buy big enough hardware. So if I do a temp table, I get the 3 rows, and it does the same thing that I expect it to do. Nested loop, index seek for small numbers of rows. Put the one guy in there, he's the big one. Very different plan. Scan and hash, which is more efficient for relatively large numbers of rows. Now you may think that 4187 rows is not that big, but the math against logical IOs, or excuse me, random IO in the optimizer, which was written many years ago now, when we had 4,200 RPM disks and maybe 1 or 2 of them in a big server. The math is so skewed against random IO that if the optimizer estimates more than about 1% of the rows in a given table are going to be touched, it will switch to a table scan as a more efficient alternative. And that can be why sometimes your query is running along and all of a sudden, one day, it starts taking a lot longer. Because you reached a tipping point where the math said, I'm affecting more than about 1%, and now it's mathematically in the optimizer more efficient to scan the table. That doesn't mean that your I/O system and server can actually make it happen faster, especially if it's fragmented all over the place and it has to do random I/O because you have 1 megabyte as your default data file growth on your file and it's spread all over the spindles. Okay? But that's why that happens. So any questions on that? Really, really, yes?
Only a hint. If you're really using the temp table, you can use option recompile to get the real estimate.
Option recompile. Mentioned again. And I will tell you, it is your friend. Another case where that comes up. You have a report query, and many report queries have a start date and an end date. Big honkin' touches fact tables and dimensions in my enterprise data warehouse. First call, just started the server up. Yesterday and today. It's a big system, 60,000 rows. Out of 1 billion, give me some index seeks and nested loop joins. Boom. Store the plan. Next call. 11-1900, 1231, 9999. All the datas. Engine says, I got a plan for you. Trillion logical IOs later, a day and a half, and I've seen queries run longer than a day. It finishes because it's going up and down and up and down and up and down. Even on SSDs, that kills you. Scan and hash. But it can't do that because it stored the plan. Widely varying input parameters and data value skew. Option recompile says, look at what I'm giving you right now and do something intelligent with those values. And by the way, don't bother storing the plan because I'm going to send option recompiling the next time too. So it saves on bloating the plan cache potentially with these massive plans. Okay. So what you're doing is you're trading CPU ticks to avoid disastrously bad executions. In Moore's law, power of CPUs goes up and up and up. Now, the speed doesn't go up anymore, hasn't for some years, but we get more cores, so we still have more processing power per unit space, right? So I will jump through extraordinary hoops to trade CPU ticks for almost anything because CPUs are nanosecond time frame. That's 1,000 times faster than direct memory access. There's nothing else that comes close to the speed and processing power of a core. Trade CPU ticks for I/O especially, but in this case we're trading it for to avoid disastrously bad plans. And it doesn't matter which way you call it. If the first one you call your big report query was all data, scan and hash, fastest way, store it. Next one, yesterday and today, scan and hash. You lose either direction. Okay? So I wish we had more time. I could talk for like 3 days on this, I think. Lots more things that we could discuss. Any questions? Anything at all? So I've got another session, and I think it's the entity framework one. Anybody verify that? Have a schedule? Is that what it is? Okay, good. I do a lot of these, plus I was sick for like 6 days before I came over here, and I'm still jet lagged. So thanks a lot, and hope you have a great Saturday.